Okay, all right. So the most important thing we need to focus on here, again, it says do not evaluate, so the integrand's along for the ride. It has not asked us to motivate this, so the phase 1 part of the problem has been done for us. We're not interested in phase 3. This is just a phase 2 problem, right? So we just need to look at the domain, figure out what that looks like, and ask what are the ranges of values in the spherical coordinates. Okay. All right, so let's draw the picture. We've got a ball of radius 4 centered at 4 on the z-axis. Let's start with that. This is 4. Cool? Yeah. Right, now let's see, what else do we know? But we're interested in the part where z squared is greater than or equal to x squared plus y squared. All right, so this is actually a chapter 2 problem. So first I want to ask, what does it look like if I say z squared equals x squared plus y squared? Right? Okay. Right, so let's write that down. Start with z squared equals x squared plus y squared. Okay. Well, this is a rotation, right? So this is a rotation. Let's say it's a it's a rotation around the z-axis, right? Because of the expression we see. And let's pick a half plane. I'm going to pick the YZ plane, just because it's easier to draw in the YZ plane than the XZ plane. And in that plane, x is equal to 0. And so I just have z squared equals y squared, which is just z equals plus or minus y. Does that make sense? Write that down.
Oh, yeah.
So z squared is equal to y squared, and therefore z is plus or minus y. Is everybody happy with that? Okay. You okay?
Yeah.
Okay. Okay, so now what does that look like? And importantly now, keep in mind, we're only interested in the part where y is greater than or equal to 0. Right, so I don't have to worry about anything that's happening. We're not interested in that at all. So z equals plus y would be that. Z equals minus y would be this. And I'm interested in what happens then when I rotate that around the z-axis, and so I get a couple of cones, right? Cones that are sort of like vertices meeting at the origin. Right. All right. So let's take a whack at drawing that then. Kind of like that. Okay. Good. Everybody happy? Okay. So that is where z squared is equal to x squared plus y squared. I want to know where is z squared greater than x squared plus y squared. So greater than or equal. So that means that I'm interested in, well, up here or down here. And so I'm interested in the part of this ball that is in the green shaded area. Well, interestingly, there is none down here, so I don't have to worry about that. Yeah.
Does that green shaded area continue up and down?
Well, yeah, that's right. Yep.
Oh, okay.
Yep. Yep. But the ball doesn't. So, yeah, right. Exactly. Okay. So now that I have a picture drawn, let's see here. I'm going to take another whack at now drawing what I'm really interested in. Tell you what I'm going to do. I'm going to. Here's my sphere. Right. Ball. Excuse me. There's the ball. And the cone that I'm interested in again is kind of like this. And that cone was a rotation around the z-axis, but then again, so was the ball, right? So how about this? Why don't I I'm going to try to view the actual intersection that I'm interested in as itself a rotation. So specifically, let's look at both of these. I didn't mean to erase that. Let's look at both of these inside of that half plane. All right, so that half plane over here. Keep in mind this is the z-axis and this is the y-axis. So my ball is all of that. Over here in that half plane, that looks like this. The cone that I'm interested in is all of this. And so all together, you can see what I actually care about is, the intersection of those. Purple. The intersection of those, which is going to be that shape. So I'm interested in that shape and how that rotates around the z-axis. All right, so it's going to be a hard thing to draw. It's like, I don't know how hard this is to draw. Let me give myself a little bit more paper. By the way, you'll notice a pattern here. I do this a lot, that I draw pictures, I learn something from them, and then I draw better pictures. And then you just go through a succession of pictures, each one of which is a little bit more relevant than the previous. Right? I think this is a good process to go through. So, new page. Trying to visualize what it looks like when this thing here is rotated. Let me observe that what we have then is this triangle down here. That rotates to make a cone. And then I have this quarter disc. And that rotates around to make a semi-ball. Right? So all together, I have a generously dipped ice cream cone. Let's see here. Okay, so there's my cone part, and then here's the ice cream, and that goes on top. I don't want to use red again. I thought that was a bad color. So, yeah. Everybody good so far? Okay. Now let's talk about our different possible choices of coordinate systems. The question says, now it says in spherical coordinates. Okay. So be it. We can do this in spherical coordinates. So looking at our solid, let's start with theta. What's the range of values of theta here? Looking at these different theta cross sections, well, theta is going to go all the way around. Right? So theta goes from 0 to 2 pi. Everybody happy with that? Okay. Now, on a given value of theta, keep in mind the slice that I'm interested in is that. Now let's talk about the range of values of phi. Well, phi starts at 0 and phi increases right up into the point where it's sort of, tangent to the cone, and that's, well, you got to think about the geometry of this situation, but that's where phi is equal to pi over 4. Let me do that.
How do you know that?
Yeah.
What is your thought process?
Yeah, so that's right. So the thought process, yeah, that's right. He's right. It comes from the fact that this line, if you recall, this line came from from z equals y. Right. We also had z equals minus y that was down here that we threw away.
Yeah.
But that one there was z equals y. Yeah, it's a 45 degree pi over 4 angle. So yeah. Exactly. Everybody cool? Right. So yeah, let's see. Let's summarize. By the way, I'll write it down here. Theta goes from 0 to 2 pi, and then let's see. Phi I did in blue. Goes from 0 to pi over 4, and now we will look at in red here for a given value of phi. For some given value of phi, so we're looking here at a phi slice of our theta slice. There's my starting value of rho. I went too far. Sorry, blew it. There's our starting value of rho on our phi slice, and then it ends when we get to there. Clearly, rho 1 is 0. Yeah. What do I know about rho at that point? Well, okay, so again, we have to think about where is the point in question? We've got that. What surface is that on? And then what's the equation for that surface? And then we'll want to solve for rho. Well, that point is on this green sphere surface. So I'm going to have to figure out what the equation of that sphere is in spherical coordinates. And so there's a little side problem that we've got to do. We've got to take the sphere, that's the boundary of that ball. And I've got to write it in rectangular coordinates, plug in the spherical coordinates, simplify, solve for rho, go through that whole process, right? And what you get will be, well, let's see here. Anyway, 0 to whatever that is, d rho. Now, what have I done wrong? I've committed a crime already, and I'm going to try to make a big deal out of it so you guys won't commit the same little crime.
Rho squared.
Yep, I wrote down d rho d phi d theta without previously writing. Yeah, exactly. So that's exactly what it is. So please worry about that. Think of this whole thing as being a single thing. It's so easy otherwise to forget that rho squared sine phi, and if you forget it, then it's a big deal, right? So, yeah. Okay, so is everybody happy with? Who asked me this question in the first place? Was it you?
Yeah.
Okay. Is that cool?
Yeah.
Okay. Everybody good? Yeah.
I have a question. It's kind of like in general, like these types of questions. So you know how you made that cross section up there, and so your phi would go from 0 to pi over 4.
Yep.
What if you didn't make the cross section and just said that, and like you looked at it like, I guess like a...
Well, I mean, you sort of have to make a cross section because when you ask what's the range of values of the second variable, it is critically only for a chosen value of the first variable that you really care about that, right?
Okay.
So here's a rectangular version of the question you're asking me. So let's suppose that our shape is like this, right? And we start by saying, well, x starts there and x ends here, right? And if you then say, well, let's just ask what's the range of values of y, and I don't want to specify x. Well, then you're going to get that y starts there and y ends there, but it doesn't on any slice, right? So what we're interested in is not the total range of values of y, but for a given value of x. On that particular x slice, that's where I want to know where does y start, where does y end. Does that make sense?
Yeah.
So and analogously back to here, you have to specify. I mean, if you've done your theta goes from 0 to 2 pi. You then have to say, well, I'm going to restrict my attention now just to a single value of theta. And it's only on that value of theta that you want to know what's the range of values of phi. Now, it might turn out that the range of values of phi depends on theta. Here, coincidentally, here it didn't. And so here, if you were, sloppy on this point, you'd get away with it. But in general, you can't. Yeah. Does that make sense?
Yeah.
Okay. Everybody happy with yeah? Mm-hmm.
Yeah. Oh no, I'm happy
Okay.
with this.
Okay. Okay. Let me stop the recording here and.